Alright guys, so today we're going to talk about analyzing binomial random variables, section 5.4. And today the big idea is we're going to cover our mean and our standard deviation. So the mean is talking about multiplying each outcome by the probability and add. And then therefore our mu, our mean, is equal to our sample size of n. So n is equal to sample size. And that's going to be multiplied times your probability. So your sample size times your probability. So P, again, is your probability. Just don't forget. So SD, or if we do a lowercase sigma, standard deviation, is equal to the square root of your n times P, your sample size times the proportion, or times your probability, and that multiplied times 1 minus your probability. All right, we're going to go through an example here and help explain this a little bit better. So let's look at this. So when the time runs out in a soccer game and the score is tied, the goal will go to a shootout. Each team gets to choose 5 players to kick penalty kicks. Whichever team makes the most penalty kicks wins. If our good old school here at VMHS, the girls' soccer team makes 60% of their penalty kicks, what are the chances they will win the game? So first of all, we'll talk about this before we can do any calculations. We want to see if this is a binomial setting. So we've talked about that, and we could use a little bit of calculations if we could, if it is a binomial setting. So again, we're going to look at our bins. Right, for binomial is bins. We're going to see if all of these make sense and it works out. So for the B in our bins, we need to have success and a failure, right? So yes, you have this, right? We have these for that because you can either make it or you can miss it. So you can make a goal or miss. Now, independent, or the independent, does one goal kick, tell you what's going to happen to the next goal kick? Does that change what's going to happen? No. So they are independent, yes. One goal doesn't change the next. And our n for a set number, right? A set number of trials. So in this case, do we have that? And they said up here, I believe we get 5 players to kick, right? So 5 players to kick. So then yes, we have a set number here. We have 5 kicks. So our trials are set up for 5 kicks. And then S for the same probability. Yeah. And it says we got a 60% chance on their penalty kicks for every single one of them. So yes, the probability is the same. So the probability is the same, and therefore that completes everything for our bins. We know we have a binomial setting. So if we're to do that, then we can go into setting up our probabilities for these. Now, we can go through all the calculations to do our probabilities. Again, that's simply by saying, using our combination, right? So our combination, all right, which is going to be multiplied times the probability of success, so your probability raised to your k value times 1 minus your probability raised to 1 minus k. Okay? And now with this, again, I know I wrote NCR here, but we can change this as far as saying this is your N and your K. Alright, so before I move forward, I get a little excited seeing that 1 minus P there, so again this needs to be N minus K, just to make sure you understand that. So this 1 minus P is raised to N minus K. In other words, the amount of failures, right? So we need to do that for each one of these. So to set these up, I'm going to set up one of them and let you know that's how it's going to play out. So for this, we're taking, for the initial one, we've got total number of 5. And then let's say for the initial one for 0, 0 success on that. And then we're going to take our probability of 0.6 raised to 0 successes, multiply times 1 minus 0.6, which is 0.4, and we have 5 failures. And that would give us our value to go into 0. And then we're going to go forth, but this one comes out to be 0.1024. And then we would simply take on, you could do all of these going forward, so you would take Alright, so that's how we come up with all the probabilities for each amount of goals we expect to make out of those 5 kicks. Anywhere from missing all 5 of them to making all 5 of them. Gives us our probability of how that works out based on our 60% probability of making a goal. So now that we have that, let's find the mean of the probability distribution. So to find our mean, again, the big idea is our mean was taking our n value times the probability and then adding them all up. All right, well, in this case, we're going to do that for each one of these. We have the probability and we have our n value. Okay. So for the sample on this one, the sample size dealing with that for n value, we're going to say for 0 goals, we're going to get 0.01024 and add them up, so forth, taking then 1 times 0.0768. So we'll do shorthand notation. If you have a lot like this, I know you know how to do that. You don't need to write it all out. You can do like the first one and do 3 little dots there, and then do the last value you'd have to calculate up. And you can just make an equal sign here, in which case this should come out to give a value of 2.9992. So we should get 2.9992. which is equivalent to the same thing as saying 3, right? So as far as we're talking about kicks, right? The team makes 5 penalty kicks many times, then we would expect them to score 3 goals on average. That's what this mean is telling you for this setup here. So again, if the team kicks 5 penalty kicks many times, we'd expect them to score 3 goals on average. That's what that mean value is going on there for the setup. All right, so now we'll look at trying to determine the standard deviation of this distribution. So we're going to look at determining the standard deviation. And again, that was simply by taking square root of the number of the sample, so the probability is 1 minus the probability of your standard deviation. So in this case, the number of trials that we had, so our n was 5. Okay, our probability was 0.6. We had a 60% chance of making the goal. All right, so that means we can simply plug these values in. So we had 5, so we're taking square root of 5 times 0.6 times 1 minus 0.6, which is 0.4. You can leave like that to put in the calculator if you need to. And that will give you 1.095. And if we're going to interpret that, we would say if the team goes to a shootout many times, their scored goals would typically vary by 1.095 goals from the mean. So technically, it's almost dealing about 1 goal from the mean of 3. Okay? And that's what they're talking about there. Standard deviation is saying it would vary by about 1 goal. They did this many times. All right, so now let's think about what the probability the team scored, or what is the probability the team scores at least 1 goal. So if our team would score at least 1 goal, what would be our probability? Well, we know the probability of scoring 0 is this guy right here. Well, if we took 1 and subtracted that, wouldn't that give us the probability of scoring at least 1? It should. So if we were to take this and say, for the probability of at least 1, you simply take 1 minus our probability of none. And that gives us 1 minus our 0.01024. The probability of at least 1 is equal to 0.98976, which is very equivalent to the fact of 99%, right? So 99% of the time, we'll score at least 1 goal. All right, so let's say the other team is expected to make 3 goals. So what is the probability that the VMHS girls team wins? Well, for them to win, we could do one of 2 probabilities. So the probability for them to win, if the other team's going to score 3, we'd want to know the probability of, let's say, they make greater than or equal to 4. Okay, so at least make 4 or greater than. Or you could make this by saying probability of x greater than 3. Because that would just include 3. I mean, that would include 4 and 5. That would exclude the value of 3. Either way you would write this would mean the same thing. In which case, we're looking at the values, probabilities for making 4 shots or making 5 shots. So all you're having to do for that, if the other team was to make 3 and you wanted to verify that VMHS girls soccer team was going to win, you'd want to say that you would take 0.2592 plus our 0.07776. When you add those up, you should get 0.33696, which is equivalent to right at 34%. So with that, if the other team has scored at least 3 goals out of their penalty kicks, then the VMHS girls soccer team has a 34% probability of winning. Okay? So with that, we played around with a couple equations there to look at, dealing with our mean and standard deviation. So again, we're talking about the mean is adding, taking the mean value is taking each outcome, multiplying it by the probability. So each outcome multiplied by its probability, and then adding these guys all up, which we did. Okay, which we did, I believe, right here. We took each outcome, multiplied by the probability, and added them all up, in which case we came out with 3. Okay, and that sample problem we dealt with. And then to find your standard deviation, you're taking the outcome, set sample size, in this case, sample size times your probability, 1 minus your probability. That came out with our standard deviation. So those 2 equations are important to look at, learn from. We guys learned a little bit today. See you next time.